So my name is Thomas Groen. I'm an associate professor at University of Twente, and one of the things I do is species distribution modeling. Species distribution modeling is a rather static snapshot in time. Hey, what are the conditions here? Is this suitable for a species, yes or no?
It's a small chance, maybe 5 to 10%.
Too hot and too dry.
I would say 0%. They eat fish or shrimp or seafood. There are no seafood on the mountains.
Yeah, I would say highly unlikely. I think they would have a terrible time there.
Blue sky, no animal, no polar bears.
There might be there if they took off their fur.
What you can do is collect a lot of locations where polar bears have been sighted, and then you can make a relationship with the environmental conditions where those polar bears were sighted. And of course this includes climate, so what's the amount of rainfall over a year, how cold does it get in winter, how warm does it get in summer. But it also relates to, for example, the vegetation that's present, and perhaps even also things like human disturbance. So you take all those things into account and then you try to calculate what is the probability that this is a suitable location for a species.
What?
And then you will see that locations where we see polar bears are often covered with snow, they're pretty cold, they've got a certain type of prey species that a polar bear could hunt on.
It's likely that there might be polar bears in that environment.
Mainly because penguins would tend to be in the same climate as polar bears. It makes sense.
Polar bears live on the North Pole, penguins live on the South Pole. If you are not aware of that fact, then of course you would think that this would be a suitable location, because it is a very snowy, icy location, so ideal hunting ground for polar bears.
There's penguin, and as far as I know, they don't live together with penguins.
So suitability versus is an animal really there is really something different, and often also has to do with the migration potential of an organism to get there. For example, because islands cannot be reached. There's a gap in between. If you would bring them there, then of course we could wonder if that would be survivable for them, because it might work out wonderfully well for them, but might also be that, for example, they're too efficient and therefore kill all the penguins.
Polar bear is much larger and they can hurt penguins.
So they would have a fantastic year of feasting on those penguins, but then the penguins are gone, and then of course the polar bear would have no prey anymore and would also be gone the next year. Perhaps a funny story, they did bring penguins from the South Pole to the North Pole, so they've introduced 2 penguins in Anchorage, Alaska. Unfortunately, they were not penguin experts, so they brought 2 females. They made a wedding for them, so they said these are our couple. So this was probably the first gay couple in Anchorage, and unfortunately those penguins died. I guess the big thing they're missing was that penguins live in big colonies, so they protect each other from the snow. And of course if you're just 2, that's a bit of minor colony, so it didn't really work out very nicely. Unfortunately this happened a lot. There's many examples known of plants and animals that have been introduced in places and turned out to be a pest or basically wither and die out. So transplanting animals is a tricky business. And this also, I think, illustrates very nicely that in species distribution modeling, it's not just putting numbers into models and then calculate some numbers out. You should also put your knowledge in of the species that you're modeling. So in this case, if I would model a polar bear distribution and I would apply that to the South Pole, then you should realize, okay, actually there are no polar bears here. So perhaps I can calculate how suitable the environmental conditions with regard to climate are, but it does not cover anything related to, prey species. Well, first of all, have a genuine interest in the object that you're going to model, right? So it is a rather statistical method or approach, but the software that is available these days is quite easy. So that's of course fantastic, but it also means that the quality control lies much more with the researcher or the person doing this. That's where actually the expertise comes in. If you want to do this, you have to learn the species that you want to model, and you really have to dive a little bit into the statistics, because with any modeling technique, garbage in is garbage out. So what is the quality of the data that you've collected? And how can you make that quality better so that actually the model predictions are reliable and say something about the species that you're looking at is, I think, crucial. So that is why, although the implementation of it has become much easier these days, of course the interpretation and making sure that you put good data in the models has not become easier. Do I have any species on my wish list to model? I just like to run those models. I'm a bit of a algorithm nerd. What I also think is that often a lot of these models have been made for iconic species, so the species that everybody likes, and I think the little bit lesser known species also deserve their species distribution model. So think of nematodes, earworms, these kind of things, little insects. I think they have a very important role to play. At the moment we have a bit of an insect crisis going on, so I think we could do much more species distribution modeling in this direction. So not so sexy topic perhaps, but I think very fundamental topic.